Hello class, so this is which rope on a wire has more tension. So it's the same stoplight. Both of these stoplights are going to be 5 kilograms total. So right now, draw a free body diagram for both stoplight A and stoplight B. So go stop, draw a free body diagram for both of them. Alright, now that you have already tried it on your own, we first need to draw the force of gravity for both of them. Both A and B are going to have the force of gravity. Then for our stoplight A, we're going to have 2 tension. These are going to be the same, going out at a 30-degree angle. And then we're going to have the same tension. I drew those a little wide. Same thing, force of tension is equal. We're going to have 15 degrees for both of them. Alright, so your goal here is to figure out which rope has more tension. To actually solve this, you do not need to do math, but you do need to think about it. So think, maybe you try holding something up with string, figure out which one you have to pull harder on, if you hold them closer together or further apart. Think about it, and then we will do some work on it. Alright, so let's think about it. So since stoplights don't fall, we can easily calculate the force of gravity. It's the mass of it times the force of gravity, so I'm going to abbreviate this as 10 meters per second squared, and we already know that it's 5 kilograms. So your FG for this is going to be 50, 5 times 10 newtons. That will be the same for both of them. From here, now you know, hey, it's not falling. Stoplights don't fall in the middle of the road. So your total tension in the Y direction, your Y tension must be equal and opposite. So you know at the end of this, you're going to have both of these add up to 50. These are going to be equal distance, equal pulling. What are two numbers that are the same that add up to 50? So your total Y tension for both of them must be 25 each in the Y direction. This is the same for both of them. So you're like, well, the tension will be the same. Well, not so. So the math on these are a little bit different than what you normally do. I'm going to erase some stuff to make room. So we know the total up of each one has to be 25 to cancel out, to have two of them cancel out the 50 newtons from the gravity. So this is where now we don't know what the hypotenuse is. That's an unknown. However, we do know what our Y has to be, which is going to be that 25. So now it's going to be doing the opposite, where we know, hey, this adjacent angle to our 30, this 25 is adjacent to the 30, so it's still adjacent over hypotenuse, but now we are solving for our hypotenuse. So it's the adjacent, our 25, over our hypotenuse. So you are going to multiply this h over, but then you're going to have to divide by the cosine. So you're going to multiply h here, these cancel out. H is now on the top, but it's not alone. So we're going to divide by cosine 30 on both sides. And so the math you're going to do for this is h equals 25 over cosine 30. Then if you plug this into your calculator, you will get, alright, so if you do the math, cosine of 30 is going to be 0.866 over 25, divide 25 by 0.866, your hypotenuse is going to be 28.9, and I'm going to just round that to a straight 29. So in A, our total tension per rope is going to be 29 newtons. Each rope is going to hold 29 newtons. I'm going to erase the math, so let's go see what about for the hypotenuse, or the tension, in our second one. So it's still, our force of gravity is still 50, and it's the same idea. We want to figure out what we already know that this has to be 25, So we want to know what our hypotenuse is going to be. So it's going to be the exact same formula, except our angle's changed. So it's still going to be the hypotenuse is equal to 25. It still needs to be 25 over, but now it's going to be cosine 15. So if you plug that into your calculator, cosine of 15 is 0.97. So now we do 25 divided by 0.97, and you will get 25.8 if you round. So your tension is larger in which one? Hopefully you're like, okay, well 29 is much bigger than 25. So there's more tension in A. So there's more tension in A. I'm about to erase everything, so pause it if you're not done writing. So more tension in A. Why the heck does this make sense? Why would there be more tension in A? All we did was change the angle. Think of it this way. If we were to break this up into pieces, for tension for B, we still have to have this 25, but it's really not going to the side very much, so we're only wasting a little energy on our X. For our A, on the other hand, it's going out to the side a lot more. So this will still be 25, but we're wasting a lot of energy pulling on this X. So the larger angle we go out at, the more pull we're going to have to hold up the same object. So hopefully this was informative. I'd said I would keep it at 7 minutes, and here we are at almost like 7 minutes. I will see you on Thursday.